You were facing a complex problem. First, you stated it properly. Then you structured it by breaking it down into elementary questions in an issue tree. Well done! Now is the time to do the actual work of problem solving, solving the problem. Now that the questions in your issue tree are small enough, they can actually be answered one by one. Each question in your issue tree is now a piece of work to do called an analysis. And each analysis requires work which needs to be planned and perhaps divided between several team members who will collaborate. This is your analysis plan. The key principle to plan work is simple. Start with the big things. You must identify the most important questions, those that have the potential to change the answer to the entire problem. Usually the 80-20 principle will apply. 20% of the questions will give you 80% of the answer. Obviously, you should try to tackle those first. As you look at your issue tree, you will see questions of very different natures. Not all analysis is number crunching. In fact, it's useful to distinguish between three types of analytical work. Type 1 questions are the ones that call for fact-finding. They have an objective answer. But questions of facts are not necessarily easy to answer. Suppose, for instance, that you want to know what is the total cost for our customers of using our product and how does that cost differ from the cost of using our competitors' products. This is not information you will find off the shelf. It requires a lot of work. But in principle, it is a question of fact. Doing the hard work of uncovering facts that are not easily available is one of the most valuable steps in any problem-solving process. Type 2 questions do not just require facts. You must put the facts in perspective to make sense of them, and to do that, you must make analytical choices. For instance, suppose you have to answer the following question. If you doubled the size of your business, how much would overhead costs increase? Your current cost structure is a question of fact, but to know how it will change, you must predict how each cost item will vary in this scenario. You will need to be clear about your reasoning. Finally, type 3 questions require judgment. These are the questions that have no single right answer. For instance, you might ask, how will competitors respond if we launch this product? Or how quickly will the market convert to this new technology? These are questions of judgment, and on questions of judgment, reasonable people may disagree, sometimes a lot. Don't be afraid of recognizing the uncertainty in these questions. Whenever possible, try to present several scenarios that cover a range of possibilities. In any case, you have to be clear and explicit about the assumptions you are making. This will make it possible to disagree about judgments in a constructive manner, not because the facts are in dispute, but because you disagree on what is inherently uncertain. Since assumptions are often going to be a critical part of your analysis, it is important to try to pick good ones. 4 basic principles can help. First, check that your assumptions are physically plausible. Try to translate them into tangible units. For instance, convert sales growth into numbers of customers, numbers of orders per customer, value per order, and so on. Second, summarize all your hypotheses on one page to check that they are compatible with one another. It may be okay to plan for very fast growth or to plan for aggressive cost reduction, but are you sure you can do both at the same time? Third, use benchmarks. Once you are explicit about your assumptions, it's often easy to find comparables to verify that you are being realistic. Fourth and last, test the sensitivity of your answer to each assumption. It is frequent to spend a lot of time debating an assumption only to realize that changing it does not really change the answer. Focus your time and energy on the assumptions that do matter. There is no good problem solving without solid analysis. Not all good analysts are good problem solvers, but it's impossible to be a great problem solver if you are not an excellent analyst.